Hello guys, so in the last 4 episodes we've been taking a look inside 2 washing machines, have salvaged washing machine motors and belt drives, have taken a look inside 2 types of washing machine motors, and the result of all of this so far has been the construction of a drivetrain for a robot based on 2 washing machine motors. The next step for me was now to look for parts to build a steering system, and while doing that I re-evaluated the reusability of a lot of motors that I have salvaged over the years, and while doing that I also developed plans for 2 self-made linear actuators that I maybe want to use for the steering, but more so for manipulators and other things that have to be installed on the robot later on. So the 2 actuators that I've built here are very slow, yet very powerful. They can lift several hundred kilograms off the ground. They can be powered by 12 volts DC, and they are way cheaper than commercial units. And here we have 2 commercial linear actuators opening and closing this gate, and as you can see they typically mimic the looks and functionality of hydraulic pistons. Now my self-made actuators might look a little different, but they still can serve a lot of the same purposes, like for example in a robot where a linear movement for a manipulator or some kind of other mechanical contraption is needed. So the motors that I ended up using for this project are windshield wiper motors, and this is a windshield wiper assembly from an old Opel Corsa, and I bought this entire assembly for only €4.90 on eBay. We have 5 wires on its connector, 2 of them, a green and a purple one, coming out of the back side of the gearbox, and these are just connected to wiper contacts or switches that we really don't need for this project at all. 3 wires remain. One of them is connected to the chassis ground, and 2 of them actually lead inside the motor and can be used to run the motor at 2 different speeds. And how that works, well, more about that in just a minute. And if you want to buy a used windshield wiper motor, I recommend to look for one that already comes with this entire assembly here, because then you already have the parts that connect to the kind of weird little rod that is coming out of the gearbox. And we take off an M8 nut, and at least in Germany that's almost always an M8 nut, and a lock washer. And then we have the little crank that sits on the tapered part of this rod. And by unscrewing 3 M6 bolts, you can then remove the motor from the rest of the assembly. And here we have a close-up of the shaft coming out of that gearbox. Its tip is just a metric M8 thread, but after that, or under that, we have a taper that is also splined. And that little crank piece fits exactly on that taper and on those splines. And once the lock washer and the nut are fastened, the crank is sitting really tightly and well centered on that shaft, and that is why I recommend to get the crank as well. But I will show you a couple of ways how you can connect other machine elements to this shaft, because that's actually one of the tricky parts with these windshield wiper motors. And by the way, that's not just in Germany or for the Opel Corsa. Almost all windshield wipers have this exact type of connection. And the cheapest motors of this type that you can buy as new parts are around €20 on eBay. And in the next step I remove the proprietary connector, because I can just use ordinary screw clamps or solder wires directly to this motor. And just in case you want to know, here's the nameplate of the motor, and my best regards go of course to all of the viewers in the United Kingdom. As you can see, the motor is still very dirty though, but just a little bit of gasoline and an old rag can help a lot here, and it looks almost new. So let's take a brief look inside the motor then. And I removed the rivets holding this metal sheet on the backside of the gearbox. And among all this grease, we find 2 wiper contacts leading to the green and purple wire. Inside, we can see a large plastic gear as part of a worm drive. And well, there is no additional bearing here holding the worm gear, so I wouldn't recommend to put a crazy amount of axial force on a windshield wiper motor like this. I also don't recommend to weld anything directly to the little shaft coming out of the gearbox because of the plastic gear and the grease inside the box. And here we have the housing holding the permanent magnets exciting this DC motor and the armature and commutator. But one thing that is really not so usual here is the fact that we have not 2 but 3 commutator brushes. And the reason for that is that this motor can be run at 2 different speeds without any additional electronics. That's what the 3rd commutator brush is for. So when we're using this motor, we're always only using 2 brushes by selecting one of the 2 wires coming outside of the motor that is not connected to the chassis ground. In this entire video, I will only use the setting that turns the motor fastest. Now, one thing that you might wonder about is if you have a car that you have typically not only 2 but 3 different speed settings for your windshield wipers. So how does that actually work? Slow speed and long intervals between the actual wiping actions. There's another one. And again, you have to wait. Takes a long time. One setting higher, slow speed but continuous wiping. And then fast speed and continuous wiping. So in short, the motor is only run at 2 different speeds, but at the lowest windshield wiper setting you have long intervals between the motor actually wiping. Okay, so enough about that. How could you use such a motor for a linear actuator? A simple way would be to buy a long M8 nut like this one. This is an M8 connector nut, 30 mm, Gewinde Muffe M8, 30 mm, and you screw that on the shaft on that gearbox, and then you just take a standard M8 threaded rod and screw that into that connector nut as well. Now you might think, well, why not just weld these 3 parts together? Well, as I said, the gear is made of plastic, there's grease in the gearbox, and well, heating this up could create a mess, and it could even melt the gear to a point where it goes off center. I wouldn't recommend it. But we'll later see in this video how this can be done in a better way. The second problem here is, though, that there is no real bearing holding the gear inside the gearbox. It's just the riveted metal sheet that can be pushed out of the gearbox when the axial force becomes too large. The next issue is that you actually don't want to use an ordinary metric threaded rod like this one as your lead screw. You want to have a long screw with trapezoidal threads, similar to what is called Acme threads in the English-speaking world. We have metric trapezoidal threaded rods like this one here in Europe. And the problem with those, though, is that they are still quite expensive and they cost like 5 or 6 times as much as the ordinary threaded rods, at least. So I thought maybe I can find something cheaper that already comes with such a trapezoidal threaded rod and a nut that fits on it, and maybe some other parts that are, well, rugged enough to withstand large forces. So what came to mind are car jacks. So what I have here are 2 used car jacks. This one is the standard issue car jack for the BMW E32, and the one in the background is a car jack from Mercedes-Benz, both manufactured by the German company Storz, and I bought both of these for around 10 euros as used parts on eBay, and they indeed come with almost everything that I need for some kind of linear actuator. But later in the video I'll try to build another model from a Chinese scissors jack that I also bought for 10 bucks. The BMW jack has this weird kind of foot here, and it's welded to the central tube of this jack in several spots. And I use a cutoff wheel and an angle grinder to cut open those weld seams. And after I have removed all those parts, there are still some edges left that I just grind off with a grinder. And now I use the hand crank to unwind this slat, or however you want to call it, until it comes out. And what we see is a central piece of steel sheet basically welded together, and then we have 2 plastic parts, and one of them has a thread inside. It's kind of the nut on which this whole thing rides on that shaft. And what we're going to do later in this video is to cut off a section of this piece and then weld a heavy steel tube to it instead. At the top of the jack we find, under this protective cover, bevel gears connecting a hand crank to the lead screw. And what I want to do is to take out the little rod that holds the top bevel gear, rotate it by 180 degrees so that I can use the straight piece of that rod to connect the motor to the jack on the back side of this tube here. But as you can see here, there is a little nose of sorts in front of that gear, which prevents the hand crank from being pulled out. So I first have to file that off, and now I can pull out the hand crank and that little rod where the bevel gear is sitting on. And then I use the angle grinder to cut off essentially the whole crank so that only the straight section of this part remains. So we can now see here that this shaft is splined and that the gear is sitting on those splines. And we can also see that the diameter on the left side is a little larger than that on the right side of the splines. And that is why I have to grind that down so that I can insert the shaft from the other side into the gear. And now it's time to build a connector piece between motor and this shaft for the bevel gears. I first punch mark this 30mm connector nut here. I then screw it on the shaft on the gearbox very tightly, and now I use the drill press to drill a 4mm hole through the connector nut and the shaft on the motor itself. Now it would be time to fit the shaft from the bevel gear into that nut as well. But the hole first has to be bored to a diameter of 7.5mm so that it even fits inside. And since I found almost the exact same parts in the Mercedes and the BMW jack, I built two different connector pieces. In one I welded these parts together, in the other one I drilled another hole and used another M4 bolt. With the hand crank removed, it was now also possible to pull out the lead screw. And you can see that the bottom bevel gear here is basically, well, kind of forged to the lead screw or connected like an old-fashioned rivet. And this gave me the chance to properly clean the lead screw and put new grease on it. But you can also see that there is simply a ball bearing sitting under this bottom bevel gear, and that means that when a lot of force is pushing from it downwards, well, you're okay, but if the force would be applied in the other direction, then nothing but the top bevel gear would hold this lead screw in place. So in other words, if we build a linear actuator with this one, it will be able to push very much in one direction, but not handle that much in the other direction. So if you wanted to change that, then you would probably have to add another bearing that kind of protects this screw in the other direction. But since I want to use this for lifting stuff anyway, I think we're good. And the next step, it was now time to connect the gearbox to the jack itself. For that I cut off two 70mm flat steel pieces, drilled holes in them, and then welded them together in an angle so that I could finally use 3 M6 bolts to connect the gearbox and the motor to the jack. And the final step was now to remove all the paint from this part here, cut off a section of it, and then weld it to the steel tube here that we saw in the video a couple of minutes ago. And I've done that, and now I can assemble the new linear actuator and we can try to test it. So I'd say that at least it's cutting very easily through that 4 by 6 centimeter piece of spruce, and I'm sure it could handle a lot more, but certainly there is a lot of room for improvement. One thing that I certainly must do is to add switches to the ends of the jack so that I can, well, tell, for example, a microcontroller when the end of the line is reached, so to speak, or this motor might destroy itself or something like that. But, well, there's actually another idea that I had here with that red scissors jack. So let's briefly also look at that solution. So what I did is to order this 10 euro Chinese scissors jack here, and I also bought another type of windshield wiper motor, this time a new one for only around 23 euros. And I bought this because this was really the rare exception, because here is a motor that does not come with that weird M8 thread and taper spline, etc., but with a crank that is simply pressed on the shaft that is coming out of the gearbox itself. And my idea here was the following. I took an angle grinder and I cut off a section of that crank so that I had a 20 × 20 millimeter square sitting tightly on that shaft. Then the idea was to build an adapter piece that would connect the crankshaft piece of the scissors jack with this 20 by 20 square. So I simply took a piece of 20 millimeter bar stock, Vierkantstahl in German, and I cut off a section, I drilled holes through that, cut a slot into it so that it would fit on the crankshaft attachment of the scissors jack, and then I took these 20 millimeter flat steel pieces, in this case stainless, but only because that is what I happen to have, and I welded them all around the bar stock. So I had a connector piece that would fit directly onto the 20 millimeter square, and now all I had to do is to remove some paint from the scissors jack, and then take some more of that 20 millimeter flat steel, cut off sections of that, and then connect the scissors jack. There's a part where the lead screw is leading through, but without having a thread. It's just holding it in place, and connect that to a part that is then holding the gearbox and the motor. And now I'm using a 12 volt lead acid battery, just as with the last actuator, to test this second model. So yeah, in short, it also has a lot of power. But I actually just built this to show you that you don't need necessarily a BMW or Mercedes jack from Germany, and that it doesn't have to be any kind of specific windshield wiper motor. And well, I also tried just to find different connections between different motors and different pieces. So I think in what I wanted to do, I have succeeded. But for a robot, some additional provisions have to be made. For example, to control a motor like this with an Arduino, for example, or another microcontroller, you need a powerful H-bridge, like this 43 amps H-bridge here that you can buy for a couple of euros, for example, here. But well, if you order it from China, you have to wait a long time, so maybe look for something that's already in your country. But I have tried this H-bridge and can recommend it. If you wanted to measure, for example, at which point the linear actuator is extended at this moment and operated in a closed loop system, you could use, for example, a linear encoder salvaged from an inkjet printer like this one. And that is what I'm going to do in the future. Also, as I mentioned before, simple switches can be added so that at least the start and end point of the possible movement of the actuator is clearly defined and can be communicated to a microcontroller. So my work here will go on, and I have already a couple of other motors lying around here that I also want to use, or at least try to use, to build actuators for the robot. And well, if people like this video, then there will be another one with more of that. But there are unfortunately a lot of things that keep me from doing my job here properly at the moment. And one thing is that a lot of things are broken or depleted. I have no more argon, the bottle is empty. My welding mask is of the cheapest kind and is broken. My welding gloves are also gone. It's getting colder, the winter is coming, and the workshop has as of yet no insulation, and I have no heating system installed. Okay, I got it. I stopped whining already. I just wanted you to understand that there are a lot of basic things here that keep me from being really fast and efficient with producing new videos. So if you like this channel, please think about becoming a patron on patreon.com/tpai. Or maybe make a donation if you can spare a buck. You can find a link to that in the video description. But be that as it may, I hope that you like this little trip into the world of the linear actuator. And see you soon, guys.